Привет. Да, меня зовут Себастьян. Я работаю в качестве евангелиста программного обеспечения для IBM. And that's about all I can say in Russian. Actually, I'm learning Russian, but I hope it's okay when I talk in English. And yes, welcome to my talk on modern enterprise Java, if there is such a thing, from the ground up. It's going to be a more, general topic talk about modern Java enterprise and how to do that, how to build that up from the ground using tools and best practices, how to use Maven, for example, how to do things like Docker, and, how to even build enterprise applications with a modern enterprise Java approach. So a few things about myself, a lot of Java titles involved, and so on and so forth. I have an enterprise Java background, and I did a lot with enterprise Java in general. And another fun fact about myself, я люблю coffee. So this is why I have a coffee shop application example. So what I'm going to show you is basically all of live coding, and then discussing some best practices and showing some tips and tricks about, enterprise Java. So I will mostly live code, so you will see a lot of this, my IDE, and then running these things. And that's already a Maven project. So who of you uses Java and Maven to build application? Hands up. Okay, a lot of you. So you probably are aware of this. I will explain a few things here, and afterwards we will have, hopefully, some questions and discussion in the discussion zone. So if you have any questions, please feel free to ask afterwards. So this is a coffee shop example application that I'm going to build. I'm going to package this as a WAR file, and there's a reason for that. And for now, I use what is called the Java EE 8 API. And just because I'm brave, I will use Java 12. Who of you uses Java 12 in production? Oh, okay, not bad. Who of you uses Java 11, 10, or not? Okay, not bad. Okay, who of you uses Java 8? Yeah, everybody else. Okay, perfect. So we're gonna build and show this, and then what I'm gonna explain a little bit is, about what else we have and a little bit of overview where we are right now. So Java EE, or what comes from originally J2EE, now it's, being fully made open source on the Eclipse Foundation. It's going to be called Jakarta EE. And I'm going to say a few things that are interesting for enterprise projects. Mostly it's, fully compatible. So the whole knowledge you have and the technologies that are part of EE will be still there in Jakarta EE. And also, there are a few things which I would call Java EE the good parts, at least according to me. So Java EE or Jakarta EE contains a lot of technology and a lot of legacy and old technology that you don't probably want to use and you don't need for modern enterprise applications. So there's a few technologies that you should focus on for modern Java. So this is what I'm going to show. Mostly things like CDI, JAX-RS. These are APIs that a lot of developers know and like. Then JSON mapping, JPA, JTA for persistence, EJB if you use the modern version, like version 3, and then, that's okay. Things like bean validation, interceptors, and so on and so forth. What is also out there, what I will combine, is this initiative called MicroProfile. Why we have MicroProfile has a little bit of historic reasons, how Java EE was under Oracle and could not really move forward for a while. So a few vendors came together to form this initiative to have more innovation in enterprise Java. And while MicroProfile is a little bit different subset of Java enterprise technologies, but it's based on the same technologies with some extensions, how I would call them. And what we see, if you look at MicroProfile, again, the good parts, there are some parts that are really helpful for enterprise applications. As you can see, they're somewhat built on the same technologies. Like we also have CDI, we have JAX-RS, things a lot of enterprise developers know. And we also have some new projects, new technology, MicroProfile config, fault tolerance, metrics, which I will show a little bit. So some ASCII art diagram from Java EE and the technology that we have. We're going to advance to Jakarta EE, which will include the same things. And also we have MicroProfile that partly includes the same technologies and also some more additions. But the good news is we can combine these two. We can use them both, which is what I'm going to do. For modern projects, this is what I would also suggest to do. So for now, that's only a Java EE project. The reason for that is probably a lot of you have knowledge in Java EE or J2EE, and then maybe you have worked with old-fashioned application servers and things like that. Who have you used IBM WebSphere in the past? Oh, izvinite. I'm sorry for you. But we will see it doesn't have to be this way. Actually, there's much better technology out there right now that, we can use why you can still have the same code. So you can modernize your applications. You don't have to write everything from scratch because it's still the same technology being included here, and you can use modern runtimes that support the same thing. Why I can use some newer additions, some newer standards to create new features, for example. So what I'm going to show you now, a little bit more live code, is some coffee shop example. So I'm going to deploy this in a second, and let's walk through a little bit of the code. This is a very basic application where we can have some coffee orders. So if we would like some coffee, we can have, I created some REST resource, JAX-REST, with JSON mapping. So we have /orders, our coffee orders, and then we can get some orders as a JSON, right? And we can create some orders. And I include some, other technology, for example, bean validation. So we have some coffee orders that are already being validated and things like that. So the very efficient programming model that we know, a lot of declarative programming approaches. And then we can use a coffee shop, for example, to order some coffee and then, store it somewhere and so on and so forth. So this is basically the application for now. And what I'm going to show you is now how to develop that locally. So one thing, and I will talk about this a little bit more, is how we built this using Maven. My Maven POM file, that's all of it here, is kind of small. The only dependency I have for now is the Java EE dependency, and that's also provided. So it means it doesn't end up in our deployment artifact. It's going to be important later on. And what else we have? I have to define the Maven plugin, the war plugin here. The reason for that is because of Java 12. If you don't use that, then unfortunately we still have an older version and things like that. And then basically what we can do in order to build this is to call, Maven clean package or Maven package, and then it just packages everything up. And that's, it's not the newest computer, it's not super fast, like 1 second would be better, but it's pretty fast to just build it. And this is one of the best practices. You should keep your build very simple. So in this case, I only have a simple build for a thin deployment artifact approach, and then I can build this, and I have, for example, a deployment artifact that I could deploy somewhere. We will talk about Docker and containers in a second, but what I will show you now is another approach while I'm going to live code a little bit, which I include using another Maven plugin. So a very important thing in my eyes is to keep the plugins, Maven plugins, or the overall usage of Maven as simple as possible. So I'm not a big fan of Maven plugins at all, because usually, in my eyes, you don't need them. I make one exception here with that Liberty Maven plugin that I will show you in a second, because it provides an actual benefit. Usually, a lot of plugins, in my eyes, don't provide a benefit, right? It's just a wrapper for something else. If you have something like a Docker Maven plugin, you can use that to build your Docker container. Or you can also call Docker build, right? It's the same thing. And then I would say keep it simple, because that just adds more complexity. What I will show you is I will actually run this on OpenLiberty, which is based on WebSphere, but don't worry. This is a very modern application server and also luckily a very fast one. With a lot of innovation, it's very fast at adopting new features, for example, new MicroProfile standards. And it supports both MicroProfile and fully fledged Java EE. So you can mix and match from everything inside there. And this is actually what I will do here. So I will just have a very small configuration. So it's main liberty config. This is a server XML configuration file, but again, XML, don't worry, it's a small feature manager feature. So we're going to include some, well, features in order to configure our runtime. And easiest one for now is to say, well, I want to use Java 8. And I also include this. I want to use MicroProfile 3.0. MicroProfile. And that's all. And then I basically configured that server. And what I'm going to do, I now call this Liberty Maven plugin. It basically says, well, Maven, and then call this Liberty Dev profile. And what it is a plugin that includes a development mode that listens for my file changes and deploys to an Open Liberty locally. In production, I don't, of course, want to do it in this way. I will use proper containers. But there is an advantage to do it this way, because then, well, I can have my turnaround times very short, because I can just change something in the code and then redeploy quickly. So what I'm going to show you is, once this is up and running, oh, unknown host. Oh, it tries to, do I have some, oh, Jesus. The Wi-Fi worked before. It's interesting, because it tries to check the version. Oh, now it works. Let's try it again, because I need the internet later. And then this is going to start up that server locally, and I can connect to it. And the nice story is, once that is being started, yes, this looks good, I can, of course, access it locally, and I can also make some changes. So let's do this. For now, I could go, for example, curl localhost, and that's the default port, 9080. And then there is some health check resource provided. That is already provided by MicroProfile. MicroProfile health, for example, that is being included there, health check out of the box. So I could use that, and then once the server is up and running, I can basically see that, and then I can, well, finally order some coffee. I can have a look at my application. Health check, now it's still down. This is an automated health check that already can be quite helpful once we use containerized environments, right? Things like Docker and Kubernetes in a second. So now this is up and running, and then I can go to my application, coffee shop. This is called orders for the coffee orders. 200, okay, that's good news, and well, it's empty. I don't have any orders in the system, right? So let's change this. Let's order some coffee. I basically have to HTTP post a coffee order here in JSON, right? So let's do this. I'm going to post some application JSON here. And how does an order look like? Let's have a look at it. Coffee order has a few things, and mostly it has a coffee type, right? Which coffee you would like to have. For example, an espresso or a cappuccino or something like this, right? Let's order some espresso. And then we have a coffee order that's in the system. Okay, great, works. Also, well, not that interesting. It's, for now, just Java Enterprise, which I will now enhance with, well, some more code and some more features. Good news about that is this is now up and running, and the process that's running in the background is just listening for file changes. So I could add some things and then, change some logic here. For example, what I will do, I include a further health check here. This now comes from, let's call this health, from MicroProfile health check. So I could have a programmatic health check to say, oh, you can check for database access and things like that to tell my application whether it's up and running. In order to do that, I now need to add one more dependency, which is the MicroProfile dependency. And again, this is a provided dependency. Reason for that I will explain you later. And these are all the dependencies we need, nothing more. So the only thing, if I want to use MicroProfile features, that's going to be it. And then I can change something here and implement some health check. That's a health check here. We're going to call this. And then this will be a CDI bean. So all of that is supported as well. And this is going to be a so-called liveness, or in this case, I want to do a readiness check. whether the application is ready to do some work. And this will be a health check response, a named response for my coffee shop application. And this is up and running, and then I can, put this together. Nice story about that is this process, my Liberty development mode plugin, will just redeploy the application, and then immediately I can say, okay, now my health check is actually there. This is this, empty health check. It's not that interesting, but now I could, for example, check for some actual status. So now this will always be okay once my application is up and running. So that's already helpful. Or I can include, for example, more data to say, I say hello world, right? Again, it's going to be redeployed immediately. So once the application is up and running again, I immediately have my changes. And this is true for all the code I have here in my application. So I can now just change anything, and it's immediately going to redeploy. So that's a nice story about that. It's, depends on how fast my laptop is. It's pretty quickly to just redeploy the whole application, because you don't need to start up everything from scratch. This is this development mode, and which I think is very, very helpful just to be more effective, right? You can just change some code, and it's going to change something here. What else I can include is, for example, MicroProfile config for injectable configuration. So we can, let's do it right here. We can inject something with @config property that also now comes from MicroProfile config, where we say this is going to be a property such as, I don't know, application version, or some default value if that's not there, or whatever. Say this is a version that's going to be injected here, and I call this version here. And then again, code is going to be redeployed, and now this version is going to be included. Now, hang on, where does this come from? 1, 2, 3. Well, MicroProfile config, you can have a look at that documentation. It has multiple what is called config sources. Again, that's all just out-of-the-box conventions. Where you can get these from, so for example, you can do environment variables, very helpful for containerized environments, or out of the box, what you can also do is MicroProfile config properties. I'm going to use a few of these, of the other ones in a second. And this is now just a version, so that's a default that I can include here. I can change this to 1 to 4. Again, this is also being picked up and then changed. That's a nice story. This plugin also recognizes the default conventions, such as MicroProfile config, what's the default path for this, and you can just take it, it's going to be updated and listened to, and you don't have to restart the whole process. It's just a little bit faster. So this is how to do, health checking and MicroProfile config. You can inject these into all CDI beans. So within your whole application, you can just inject with this, it's a qualifier actually, and then just have some injectable configuration here. All right, what else we can do? Let's have a look at the structure of a project here for a second. So again, I'm a big fan of keeping things simple. So typically for my application, I'd like to have a single project, which is now here the single Maven project. And if I have something like modules or some modularization in my application, I typically want to have this as packages. The reason for that is if later on I have only a single deployment artifact or a single deployed application, then for me there's no reason to build this in multiple Maven modules, right? If you don't have another requirement. So I see this in projects sometimes, but if everything boils down to a single application, in my eyes, it really doesn't make sense. And the packaging, it's a little bit small. The packages names are health for this health check, orders, and I have another one for price. That's another story how to architect your application and how to structure it. I'm a big fan of calling these structures and these names based on your business requirements, based on your domain. So don't name the top-level packages, something like persistence or DAOs or exceptions, technical structuring, but structure them by business domains and names first, because then it's obvious what your application is about on a business perspective. There's a term called screaming architecture. Like this architecture screams literally that it's a coffee shop system, right? It doesn't scream, hey, I'm a J2EE app, I'm a Java EE app, I'm a Spring app. No, it says I'm a coffee shop application. And that's the important thing, I believe. Or else, what else we have? With MicroProfile, for example, you can include some other things such as metrics or tracing, fault tolerance. So this is, again, just a few standards, a few features that are included there. Or now what we can also do is some little bit more live coding, since our application is up and running. So what we could do, for example, is to enhance our application now a little bit. I have a structure here that's called price. So for example, I could now include, well, some price calculations, right? Let's do this. So if I have a coffee shop, let's say, my coffee order should now also include some pricing information. So let's say this, I have a type, and then, just for the sake of the example, let's have integer in ruble, for example, type. So let's include this. I include some price information here. And then what I want to do, I want to have another component that just calculates my prices, right? So I inject my price calculator. By the way, you check for typos. So if I make mistakes, it's your fault as well, right? You just tell me. Because live coding, everything can go wrong. So that's a price calculator here. The packaging that I use, and there are multiple ways how to do that. I use the standard that's called a BCE, Boundary Control Entity. So the boundary package is typically all use cases. So the entry point of our use cases that we have. Again, business-focused packaging. Control are just all transaction scripts, what's called in DDD, or just any components that are somewhat involved in our business use cases. And entities are, the domain entities in our application. So if we have a price calculator here, then let's say, what we're going to do is price calculator, calculate the price for this coffee order, right? It might be different depending on the type and everything. So this is going to be an integer, calculate this price, and then we're going to set this price depending on what we calculated here. Okay, easy. And then, how we're going to calculate that, I already showed you. We can, for example, use some configuration here. Let's configure the prices based on the different coffee types. So we could have the configuration again, but now in this case, it's not an injectable configuration. It's not a declarative approach, but a programmatic approach, like depending on which coffee types you have, for example. So if we say, let's say, get configured prices, or get configured price based on the order type, we can say create a method here. This is going to be the int, depending on what is configured here. And then what we can say, return a config, and there is a config provider where we can say, okay, give us this config object, and then we can actually have a programmatic access. For example, for coffee prices, coffee prices, and then depending on the type, the enum name, and then we're going to look up this in, of course, an integer. So that's one way how to do this, right? And then we have, the coffee price here, price, and then we can return this, right? Calculate price, return this price for the coffee order, and then we have this in that way, right? What we can also do is to include some discount. If we say, we want to have some, let's do something more sophisticated. Let's have some calculations here. Let's calculate a discount that, again, we can configure here. So, for example, return calculate discount depending on the price. So, for example, we create another not high int. We create another method here. And now what we're going to do, now we can again inject this configured value. It's just easier. We could also do the programmatic lookup, right? But it's just easier to do this. Coffee permanent discount. IntelliJ helps us here. Default value, let's say it's 0. There should be no discount here. And the injection will, of course, detect what type of what type you have here. Let's say you have a permanent discount, and now, well, you have to help me. How do we calculate this? Discount times the price, right, is gonna be the discount. Math round. Please never do these math calculations on prices, right? And what we're gonna do, well, the price minus the discount, right? Something like this. Well, that's gonna be a long, that's fine as well. Or not. You get the idea. Right. So, then hopefully, source compilation is an error. Let's try this again. So again, this Liberty approach here is just constantly gonna compile and reapply my files here. Let's see this, did it compile something? Let's see if that works, orders, yes. And post, create a new order. Should be fine now. Now I have a new order in the system, and now I can see, well, what price we have for that. So if I access the single order, oh, price 0, okay, that probably this compilation not goes so well. So in the worst case, you just have to restart that process, but ideally it can just, reapply these things for you. Oh, okay, that's still the old status here. Let's quickly restart this. That's the worst case that can happen, and then you just have to wait a little bit more. But typically, what you can do, you just can continue developing as long as you go, for hours and hours, and we'll just constantly recalculate and recompile whatever you have. And then this is just easier for us since we typically don't have to restart the application here. So then we're including some price information, and that is now configured in this file, and then we can application startup just configure something here, or while we're developing, as you saw before, we can even change the configuration and it will detect the changes. So these are a few things that we can do. Again, we can also include things like metrics. You can have a look at MicroProfile metrics that has a similar approach where you can declare your own metrics in the Prometheus format, for example. So of these cloud-native technologies, there's a way to include Prometheus and Grafana, if you heard of these monitoring technologies, out of the box. That's the nice story if we use these modern approaches, and especially modern runtimes that support that. Okay, this looks good. And then it's just easier for us to, well, integrate that in a more modern approach here. Okay, let's have this, and now we have a new coffee order, and see, yeah, now we have the price, which should be 80 rubles and whatever, some discount. Calculated, I hope it's correct. If not, you can check out the source code later and fix it. All right, so these are a few things that I wanted to show you. So that's about this. Metrics, what I just called you, metrics. There's some metrics that are included. So out of the box, they are available. So this is MicroProfile metrics, another project that's available under /metrics. What OpenLiberty does, it says, well, these metrics are super secret. We don't want to have them over HTTP, but please use HTTPS and authenticate. And now I'm, to be honest, too lazy for that. So what I can say, well, I don't care about this, to be honest. Metrics, authentication, false. Authentication, false, yes. And then again, it would just, well, reapply this, and then it's accessible. So what you see here, that is not broken, it's meant to be this way. It's the Prometheus format. So that is a format with which you can have some monitoring data, some metrics from your application. So your application emits these metrics, and then Prometheus and some other technologies just scrape these metrics and can display it. If you're interested in that, I have more material on that, how to include that. And it's very helpful for modern cloud-native technology to just include this out of the box. As you've seen, we don't have to configure anything here in our project. It basically works because we use this MicroProfile feature that includes MicroProfile metrics, for example. Again, if you further want to optimize this, you could instead also have all the individual features being listed in your server in Liberty. So this is just because, well, I'm lazy to do that. And I'll talk about this a little bit more, how helpful it is. But what you can also do, you see here a list of installed, well, sub-features. For example, Java EE includes, JAX-RS, CDI, EJBs, and tons of things. And if you say, hey, wait a second, I don't care about EJBs and all these other things, I just want to list the exact features that I want to have. For example, JAX-RS, CDI, and JSON, and that's it. Then you can do that, and it's a small optimization. Then your runtime will start up faster, but you don't have to do it. It's a runtime optimization, and that's an important point that I make, because you should keep the number of dependencies small and simple. So just include, Java EE API, and then you can use the APIs, because you do not ship these dependencies. It's all provided. All right. What else we can have? For example, let's talk a little bit about tests, and that's an interesting topic as well. If you go for a Maven approach, because ideally the Maven build is simple, and we use the conventions that we have. The conventions are usual unit tests or Maven tests, surefire tests sometimes called, and they're also fail-safe or integration tests. And there are two conventions. If, for example, we call something, let's call this coffee shop test, and then let's include some more dependencies for testing, or JUnit and some JAX-RS client. So now these are a lot of dependencies, but don't worry, all of them are test scope dependencies. So that's okay as long as we're in test scope. They will not be shipped to anywhere. I use JUnit 5 for testing. So for example, we can say, I want to have a test here, and of course, I only output something. I don't really assert, right? That's what we do. And then basically what I can do, I can, for example, use this plugin to say, oh, now please run my tests here. And, well, it will execute this one here, or I just go the default Maven way. Let's stop this application again. And what I typically do, I include Maven clean package, and per default, it will just run these unit tests, right? Easy. And now I have one test. That is super helpful. One test, great. Super test coverage. What we also can do is integration tests. And now, if you're interested in that, I will actually give a talk here in St. Petersburg on Tuesday for the Java user group on the whole topic of effective enterprise testing. So that's, of course, a whole topic on its own. But let's say we want to have an integration test, and here it's going to be a test that is testing the application as it's already deployed. So that's also a longer story, but I'm not a big fan of firing up an embedded simulated container, such as Achillion, if you know about that, or in the Spring world, Spring tests that do very much the same. Because if you're in a more complex project, at least from experience, they very quickly become, well, too slow. So you fire up, hundreds of them, and if you don't further optimize them, you really slow down your build time. So let's see, test the system running, for example. And what I already included is some coffee shop system, some subcomponent that I can just instantiate here and say, oh, please assert that, hello, assertions. Assert that the coffee shop system, coffee shop system is up. It's true. Okay, perfect. And another test, for example, the application version, right? So assert, why didn't it use my static import? Assert that the coffee shop system is, get the application version. So the application version is, by the way, 1, 2, 3, is the one that I included in my health check. And now I can run these tests as well. And the nice story about that is, yes. The test will fail. Why? Well, the application is not deployed. So that's a nice story about that. If you would do this in a more, in a faster approach, what you can do, you can run your application locally, and then you can very quickly fire up these integration tests. Not quickly as now, because the application was not running. But ideally, you change something in your code. You now saw half of the workflow, and then it immediately will restart and redeploy your application. And then you can quickly fire up your integration test that, in this case, well, you already guessed it, has an HTTP client to connect against, local host and say, hey, please give me the health check resource and check that, the status is up. or give me this data of the health check and see which version do I have, right? So once that is up and running, you can see curl localhost. Let's check this here first, whether this is up and running. No, it's not. Health check, that has been launched. So let's give this a little bit more time, and then we can run the integration test. Again, if you're interested in that bigger topic, we can have a chat on that on Tuesday. Other than that, who of you knows about containers and specifically Docker? Hands up, who has used Docker? Okay, let's continue a little bit more on this topic, how to include this in a more, well, cloud-native modern approach. Let's write up a Docker file. And there are some conventions about Docker containers, for example, like how to build them up and how to keep them simple and small. So what I'm going to write, well, we have a base image typically. That's a nice story. We don't have to redefine everything from scratch. But I can say, use something like OpenLiberty in some version, Java 8, Java 12, for example. So that's my application server, base image plus Java plus everything it needs, right? And then what else I need? Well, that is my application, my WAR file. So I have to know about this structure, where to put it, and that's it. That's all I need in my Docker file. Well, not quite. If I have some configuration like I had, source main liberty config server, put this to config, and now that's it. So what it does, well, it adds my application, but that is a very small application. It's a thin deployment artifact. I can show you in a second. It adds some configuration, you know, one file, server XML, and that's it. It needs nothing else in order to run my application. By the way, now since it deployed, let me just quickly run this integration test and show you that the integration test, of course, fails because of the version. I reconfigured the version before, right? That's good. Never trust a test that only was green. Now we can change this, or again, I can redeploy my application, and then I can run my tests. So this is how tests have to be run, you know, fast. I don't want to wait, you know, 10 seconds for this stupid container to start up. I just have my already running application. I can change something very quickly, hard redeploy, and now I run my integration tests. And of course, I should usually test some business logic. Now I could create some coffee order. I could check whether the order is in the system, right, and all these things on Tuesday if you're interested. All right, now for Docker, what I want to do, let's stop this again. I can now build my application like I did, Maven clean package. So I did this before. It builds my WAR file. This is fast because it doesn't include any dependencies. Well, it now tries to run the test. By the way, it only runs the unit test. If you want to run the integration test, you have to call the Maven failsafe plugin. I would say that's best practice. Why? Because you have this separation and you use the Maven conventions. So that's just the default. It uses the integration test. It ends with IET for integration test. And then you don't have to configure anything. You just save, you know, a lot of XML. Anyway, now I want to build this in Docker, right? How we do it is Docker build, and I call this, you know, username, coffee shop, let's say temp, and then I build it. That's it. Fast, quickly. Why? Well, because everything is super easy and small. That has been cached, this has been cached, and the WAR file is, well, tiny, 15 kilobytes. That's the reason why I want thin deployment artifacts. It leverages this approach of Docker and containers with the what is called copy on write file system internally. And of course, that's much faster because target coffee shop, this only includes the classes I write, you know, literally the compiled Java classes and nothing else. Everything else, well, is already known to my server. My server knows about, you know, Java EE and MicroProfile. If I include some third-party dependency, first of all, I, as a consultant, would ask, why do you need a third-party dependency? Is it really needed for the business problem you're trying to solve? Or are you just including another logging framework, right? If you need that, then you can include it here in a lower Docker image layer, and then include it, for example, in your lib folder in your application server. So basically install that in a previous layer. Why? Your Docker approach caches all these layers individually, so every step here, every command in your Docker file is going to be a layer later on. So that makes things easier. And building, well, is one thing. That's fast. But actually what is more important, once we transfer it, if we say a Docker push, because the whole image now is, I don't know, a few hundred megabytes probably, but I don't care. What I care about is the diff, how fast I can push, and depending on how fast the Wi-Fi is, you saw it was like 20K in total to push, and that's it. Because I don't change much. My application code is not that much. But if I would have a fat jar approach with 40 megabyte, then I push something, I push 40 megabyte all the time because the whole file has been changed, it has to repush, but 99.9% didn't even change. This totally doesn't make sense. And I kid you not, I used airplane Wi-Fi before to push Docker containers. Because if you use this approach, like 15 kilobyte, it doesn't, that's smaller than a website. You can do that. And of course, it's faster. And for continuous delivery, if you build, many, many times a day, it's just much faster. You don't have to wait. So that's an important approach when to use Docker. What else we have? Kubernetes, container orchestration. Who of you uses Kubernetes somewhere? Okay, a few of you. So that's also a topic. We can quickly at least show this how we would do that. But basically, if you know how Kubernetes somewhat works under the hood, what we basically do, we tell a technology how to run our Docker containers, right? I just built a Docker container. I could now fire this up locally. Actually, I can Docker run, right? Or Docker run with the correct port. Daschner coffee shop, right? Temp. Please run this, and then it runs my application server. But how to run this in production? Well, not like this, but I probably have more than just a laptop. I have a whole Kubernetes cluster, which I could use to deploy my workload. So for example, what I could get is some managed Kubernetes. Let's just quickly have this to have another demo. You could install one using Minikube or many approaches, or you can have a managed Kubernetes. I use the IBM Cloud managed Kubernetes here. And then you have things like kube control to access your Kubernetes cluster, right? And you can say, kube control, give me the services, like microservices that I have, or give me the pods. Pod equals to a running application, to a running container, for example. So now you saw it also works with Docker. And then what I could do, I could use kube control apply to basically apply these resources. So that is, of course, not only a question for enterprise Java that works with everything you package in a Docker container, but as we've seen before, a Java enterprise approach, especially with thin deployment artifacts, just in my eyes makes a lot of sense to run this as Docker containers and in a similar approach. And then, of course, you have the abstraction. Then it actually doesn't matter if it's Java enterprise or Spring or Node.js or .NET or something else. You run it in your environment by deploying this Docker image so and so many times. I have one replica. I will create one what is called pod, and then I have a service, a load balancer that is that will make sure that the whole thing will be accessible, and then I have an application that then soon will be up and running, and so on and so forth, and then I can access it in a second. So that's that's somewhat next level on these cloud native journeys and how to include that. But the most important thing that I wanted to show you today is, well, how to use a more modern approach of enterprise Java, and that you don't have to connect in your head Java Enterprise with old WebSphere or application servers that we certainly don't want to use just because they're impractical and way too slow. But there's a lot of innovation in the whole enterprise Java scene. You may have heard of this Quarkus approach by Red Hat. That's also very modern technology using native compilation and things like that. But it uses the same specifications. It uses things like JAX-RS, CDI, and the technologies that we know. And that is also, I would say, one of the most important takeaways for especially enterprise Java. If we're in projects, especially if we're in some projects or environments where we have knowledge in enterprise technology already. For example, you know about CDI and JAX-RS, right? So this is somewhat just the natural approach, the next level of what is going to be out there tomorrow in Jakarta EE and the Eclipse Foundation, and with modern runtimes such as OpenLiberty and other application runtimes that luckily have not much in common with the slow past. So what I would say, that this technology is especially interesting if you already have existing investment in Java Enterprise technology. For example, you used things like WebSphere in the past or other application servers, and you have applications that use all of these APIs. Now, the point is you don't have to rewrite all of them from scratch. You can literally just use more modern runtimes that support, an approach like Liberty does, and you can reuse, well, all your code because that's still supported, and use more modern technologies for more features or gradually migrate to newer approaches. But you don't have to throw everything away. Especially, I think Jakarta EE plus MicroProfile is some awesome technology. And just in general, keep it simple, especially with these approaches, especially the builds, like Maven builds. You don't have to overuse that. Everything I showed before is basically sufficient to run such an application. And we have done that many, many times. Very basic Maven approach, even without this Liberty plugin, if you like. Docker approach to Docker build, super fast Docker push, and then you don't do this locally. Of course, use some continuous integration and continuous delivery pipelines. That's, of course, the other interesting takeaway. Once you take it further, invest in automated testing, in automation in general, and of course, in proper ways how to deliver your software, just to deliver value. And that's also one of the takeaways that I want to give you. Focus on what solves your business problems. So don't focus on which type of logging technology or anything else on the implementation side you would use, but actually what solves the problem on my business domain. Other than that, I hope that was helpful, and spasiba, and thank you very much for your attention.